So this is how to solve your homework problems, mole-to-mole calculations, worksheet 1. So let's go ahead and jump right in. We'll do question number 1, although I think we probably will have worked this out in class. So the question is, how many moles of potassium oxide will be formed when 1.52 moles of potassium reacts with oxygen according to the following reaction? We want to take a quick check and make sure that our reaction is balanced, and that is balanced. We've got 4 potassium on one side. We've got 2 oxygen on both sides. So we're ready to get started. This is a type of thing, remember, when we're given numbers in our question, and we've got how many moles, we're going to want to use the known and unknown. I know I'm giving 1.52 moles of potassium. I'm asked to find the moles of potassium oxide. This is where you really do want to get into the habit of writing the chemical next to the knowns and the unknowns. These are going to be getting more and more complicated, and the knowns and the unknowns are going to help you keep on track. We're going to follow the same procedure we always do. We're going to put the known over 1. Notice I'm also writing the moles of K, of potassium, because I'm going to need that so I don't get confused with other moles of other compounds. This is just a normal dimensional analysis problem. If I have moles of potassium on the top, I'm going to need to have moles of potassium on the bottom. Well, I look in my reaction and I see that I've got 4 moles of potassium per every 2 moles of potassium oxide. Now I'm asked to find the number of moles of potassium oxide. So my moles of calcium are canceling out, and I'm left with the number of moles of potassium oxide. So I'm going to multiply everything together along the top, just like we always do. And I'm just going to write this down for the sake of being complete. 1.52 times 2. So I've multiplied everything together on the top, and now I'm going to multiply everything together on the bottom. I've got a 1 times 4. And now I'm ready to put that in my calculator and solve that. It's going to be 1.52 times 2 divided by 4. So my total is 0.76 moles of potassium oxide. I'm going to double check my significant figures. In my calculator, I got 0.76 moles of potassium oxide. I need to have 3 significant figures. My actual answer is going to be 0.760 moles of potassium oxide, so that I have 3 significant figures in my answer. And that's what I'm going to put in a box. All right, now we're going to move on to number 3. How many moles of sodium are needed to react with sulfuric acid to produce 3.75 moles of sodium sulfate according to the following unbalanced reaction? So I'm going to still write my knowns and unknowns, but because I'm going to do a little bit of work underneath my formula, I'm going to put it over here to the side. My known is 3.75 moles of sodium sulfate. Just to make it a little shorter. And that's going to be Ne2. And now I need to find out how many moles of sodium are needed. So there's my knowns and unknowns. And I'm going to put them in a little box just so they're off to the side and I can refer to it. Now I have to balance this, so I'm going to go ahead and use my tally method. I've got sodium, I've got hydrogen, I have sulfate, and of course I've got the same on the other side. On this side I've got 1, 2, 1. On the other side I have 2, 1, and 2. So I'm going to start with the sodium first, and I'm going to stick a 2 right there, update my total. I've got 2 hydrogens on both sides. I've got 2 sulfates on both sides, so it looks like I am completely balanced. All right, so now I'm going to go ahead and work this problem. I'm going to take my known, 3.75 moles of Na2SO4. Again, I'm going to make sure I write that compound down because I don't want to get it confused with something else. And if I have sodium sulfate on the top, I'm going to need to have sodium sulfate on the bottom. And I have to go back up to my equation. Remember, these are all ones. So I have 1 mole of sodium sulfate as my reactant. I'm going to just erase my tally method here just to make it a little bit less confusing. Let's get rid of that because it's already balanced. All right, so I have 1 mole of sodium sulfate on the bottom so that my units will cancel out. And now I need to find out what my unknown is how many moles of sodium. Well, I can see from my chemical reaction that's balanced, I need 2 moles of sodium. And now I'm ready to put that in my calculator, and basically that becomes 3.75 times 2 over 1, which is going to equal, that equals 7.5 moles of sodium. And double check my sig figs. I've got 1, the decimal is present, so 1, 2, 3. I have to start from the Pacific. So I'm going to need to have another significant figure, so that means 7.50 moles of sodium is my final answer. All right, so I'm ready to do number 5 here, which is a more complicated equation because it's not giving me the word equation or the formula equation, so I'm going to have to do both. So I'm going to go ahead and start the word equation first. I'm going to look at it, how many moles of oxygen are produced, so that's going to be one of my products, when this amount of magnesium chlorate decomposes, which means breaks apart, into magnesium chloride and oxygen. So let's go ahead and write this word equation first. So the magnesium chlorate is going to decompose, so there's one reactant, into magnesium chloride and oxygen. If I could spell oxygen, that would be good. There we go. All right, now and now I need to do my formula equation. So I've got magnesium, so that's going to be M. Actually, maybe I'll change colors here just to make things look a little different. Mg, and that's going to have a positive 2 charge. Chlorate is ClO3, and each of those has a negative charge. Magnesium, positive 2, and chloride, that must be chlorine, with a negative charge, and I've got my oxygen. So the formula will be and I'll need 2 of those. And I'll need 2 chlorine. And now I'm ready to balance the chemical reaction. I'll put some space there to put my numbers in. And I'm ready to go. So I've got magnesium. Now I'm looking at the chlorate. I don't have a chlorate ion on the other side, so I'm going to break this chlorate apart and just do chlorine, and I'm going to do oxygen because I really don't have the polyatomic ion on the other side. So I've got 1 magnesium, I have 2 chlorine, and I have 6 oxygen. And remember, anything that's inside the parentheses is multiplied by the number outside. So I've got 2 chlorine and I have 6 oxygen. On the other side, I've got 1 magnesium, 2 chlorine, and I have 2 chlorine there. So if everything's balanced off, if I put a 3 in front of the oxygen, and update my totals. And there I go, and I'm all balanced out. So I'm going to get rid of this because I don't have quite as much space. Hopefully you guys wrote it a little bit smaller. And now I'm ready to work the problem. So I have a known and an unknown. I have 5.12 moles of magnesium chlorate. And I have my unknown I'm asked to find is how many moles of oxygen. Just put a box around that so it's kind of out of the way. And I'm ready to start my problem. I've got 5.12 moles over 1. So I've got moles of magnesium chloride on the top, so I better have moles of magnesium chloride at the bottom. And I go up here and I see my coefficient for magnesium chloride would be 1 mole of magnesium chloride. I need to find oxygen. So I look over here and I have 3 moles of oxygen. So I put that in my calculator and it's going to end up being 5.12 times 3, of course, over 1. And that equals 15.36 moles of O2. I checked my significant figures. I've got 1, 2, 3, so I need 3 in my answer, which means 15.4 moles of O2 will be my final answer. And there we go.